Hey everybody, in this video we are doing yet again another right triangle trigonometry problem. In this example, comparable to most, we have two sides of a right triangle labeled for us. We also have our angle theta indicated. In this case, it is indicated in the lower right hand corner of the picture. And we are being asked to determine the tan of theta. It's important to note that nearly all of the time the figures for such problems are not drawn to scale. So you shouldn't assume anything about the picture. Will they be drawn to scale sometimes? Sure. And another thing, don't label them 30, 60, 90 if they're not a 30, 60, 90. There is nothing here to indicate 30, 60, 90. If instead of 15, if this side were a 10, that would mean this is half of this, then yes, you have two pieces out of three. You have enough information to determine that it is in fact a 30, 60, 90, but right now you don't know anything about that. So what do we need to do? Couple things, decide on your approach. We need to determine tan theta. Well, tan is a mathematical operation or a function, a rule. Theta is a variable. It's our unknown angle. So that's similar to saying like, just down here, I'll draw over here. Tangent is like saying the square root of. Theta is like saying x. And perhaps you're being told that that the square root of x is equal to 9 over 4. Okay, then what does x equal? You would do the inverse operation. You would square both sides. X, you square the square root, the square and the square root, bye-bye. And you're left with 81 over 16. You would square that as well. So we square that and we square that, blah, blah, blah. So square root's an operation. Tan is an operation. It's a rule. It has its meaning. Tangent of an angle is equal to the ratio of the opposite to the adjacent, the ratio of the opposite to the adjacent sides when theta is an acute angle inside of a right triangle. So that is just what it is. That's its definition. Every single angle that is 30 degrees, 20 degrees, 15 degrees, etc., whatever degree measure or radian, whatever measure will have the same ratio of opposite to adjacent. So you can use that then to work backwards to find angles. Anyhow, I digress. Let's keep going. So tan of theta, I wrote the rule first to prove to my teacher, whoever's grading my work, that yes, I do know the rule for tangent. Allow me to write it down for you. Now, you may also want to let your teacher know that you actually know which side of the triangle is which, because some people will know the rule, but then they plug the wrong numbers in. So here's theta. Which side here is the hypotenuse? If you said this one, you're a genius. Which side is the opposite side? Stop getting this wrong, please. The opposite side is completely across, opposite from theta, all right? And then the adjacent side, adjacent means next to, it's next to theta, like the hypotenuse, except it's just not the hypotenuse. The hypotenuse is always across from your right angle in this context where we're working inside of a right triangle. Now, small problem, it appears we're missing our adjacent side. So what does that mean? Well, we could start 5 over blank or what? So there are two ways to approach this problem. There is the impulsive, maybe harder way to do the problem. And then there is the more thought out, smarter, not harder way to do the problem. So I'm going to show you both. First case, you have two sides of a right triangle. You want to find the third side. Obviously, hopefully by now, you know you use Pythagorean theorem. 5 squared plus x squared equals 15 squared. Leg squared plus leg squared is hypotenuse squared. 25 plus x squared equals 225, not 125. 125 is 5 cubed, not 15 squared. Subtract 25 from each side. I'm just going to continue over here. X squared equals 200. Take the square root of each side. We're dealing with lengths, so I'm only going to look at the positive answer. Square root of 200. 200 is 100 times 2, and 100 is a perfect square since it's 10 times 10, right? Guys, the square comes out of the square root, okay? It doesn't stay inside. Got it? Takes a pair to make a square, so that 10 comes out because you took the square root of that 100 and you got 10. And you're left with radical 2 because there's no perfect square in that. So that is this side right here, 10 radical 2. So 5 over 10 radical 2. I can simplify. I can reduce 5 from top and bottom. That leaves you a 1 on top, not a 0. Don't be silly. 2 root 2. Oh my goodness, we have a radical in our denominator. That is definitely not allowed. For a rant on that, see a future video. Multiply on top and bottom by root 2. What is this process called? If you said rationalizing your denominator, I love you very much. So from there, tan theta equals 1 times root 2 is root 2. Here on bottom, root 2 times root 2 is not nothing or 1 or gone. Bye-bye. No. Radical 2 times radical 2 is radical 2 squared, which is 2. Or it's radical 4, which is 2. And then that 2 times the 2 outside is 4. And there's your answer. So that's, I would say, the more impulsive, just go for it right away approach. What about the think smarter, not harder approach? Okay, if you notice, your sides in the triangle have the greatest common factor. What could we do? Well, I'm glad you asked. Let's just use a marker. So if I divide everything by 5, then I look at that like it's a 1. I look at that like it's a 3. Be careful that you don't think you divided by 3 and then later multiply by 3. Just keep that in mind. Pay attention to what you're doing. Write it down, okay? Now, what I'm going to do instead is Pythagorean theorem with these numbers. It's great because they're smaller. 1 squared plus, I'm just going to use a different letter, m for maroon. M squared equals 3 squared. 1 squared is 1. Plus m squared equals 9. Subtract the 1, m squared equals 8. At this point in my life, I know that the square root of 8 equals 2 root 2 because I've done it a million times. Then tan theta equals opposite 1. I'm going to use the 1 over adjacent, which is 2 root 2. If you needed the actual length, could you scale it back up? Of course. You would multiply by 5 and you would get 10 root 2. So the outside number only would multiply. But why do that when you put it in a ratio, you're going to reduce 5 from top and bottom anyway? That's so silly, you know? So 1 over 2 root 2. And where are we? We are immediately at this step. We had to deal with smaller numbers the whole time, and we're happy and on a roll, right? So again, multiply top and bottom by root 2, and you get root 2 over 4 for your final answer. Sorry, I'm running out of space in this corner, but the end. That's it, okay? So that way is easier. If it's not a Pythagorean triple, this is not a 5, 12, 15. The triple you're thinking of is a 5, 12, 13 triangle. It's not a 30, 60, 90. It is not any of those things. Just do Pythagorean theorem. When in doubt, do Pythagorean theorem. It essentially works all the time. I hope you enjoyed that. I hope you thought it was helpful. If so, go right ahead and give the video a thumbs up. If not, go ahead and give the video a thumbs down. Write a comment. Tell me anything else you might need me to do to help you out. And click the thumbnail for another video or just watch for more uploads. Adios.